So this session will represent the work of the small uncrewed aircraft and autonomous platforms data working group about how to best collect data, and manage your drone data. So we will go through different aspects from ethics to interoperability. So first of all, I would like to acknowledge and celebrate the first Australians on whose traditional lands we met, and we pay our respect to their elders past and present. So for those who don't know RDA, it's a community-driven and non-profit technology-neutral platform, and it's focus on openness, consensus, harmonization, and inclusivity of related data aspects. So if you want to go and have a look on the RDA platform, please go ahead. Housekeeping rules. So this session will be recorded, and you can add your name on the collaborative note-taking notes, and please keep your mic on mute. So first, we will present the RDA Tiger project and introducing also the small uncrewed aircraft and autonomous platform data working group, the methodology and the use case compilation, and the first recommendation how to best collect, manage, and publish data. And after that, we will have a discussion on what we are missing on this recommendation, and we'll look for your feedbacks. So first of all, what is RDA Tiger? RDA Tiger, it's a European-funded project. It started 2 years ago, and we finished this year. So it supports the RDA working groups activities. So it's have supported service according to that on facilitation to help the management of the meetings of the working group, on helping also the dissemination of working group activities, on the communication support service, also the output service on the maintenance of the facilities, and also the landscape, who provides landscape analysis on new activities or related initiatives that could fit with the working group activities. So it's not only support services, RDA Tiger, it's also funded, helps to funded projects like expert support, the third grant, party grants also for adoption, but also the direct working group support with financial grant like the travel grant. And through this travel grant, we have the chance to have to fund 2 members travel for this meeting today. So I will start with Menti. So if you can scan the QR code, and I will give the floor to Sarah. Thank you.
Hi, everyone. Yeah, go ahead and give a scan to this, and then we'll go through just a few introductory questions before we get into the presentation. I'll just give a moment for everyone to scan. Oh, yeah. Okay. So just the first question there is, oh, there we go. No, how do we get back from there? Where you're from. That's question number 1. We just want to kind of get a poll of which countries everyone's been visiting from today. So should pop up on the screen as you put in your answers. You want the QR code again? Yeah. If you go to, is it just mentimeter.com? Yeah. Yeah, no worries. Okay. Bit of range there. A lot of people from here, so that's fun. The Antarctica one, is that okay? Cool, okay. If everyone's answered, we'll head to the next question. So, how familiar you are with RPAS mission planning, and by RPAS we mean remotely piloted aerial systems. So mission planning, data collection, some processing pipelines, metadata and storage, and data publication or reuse. Okay. Seems to sort of be even across on the lower end of not familiar, so that's great. That's why you're here today, so that's good. I'll give it a couple seconds, but moving on. So here we've just got introductory discussion and questions, and I will pass over to Alice to start.
Yeah, so this meeting will be still working, and so if you have any question, you can still put the question along. And we will have 2 breaks where we'll have some discussion and go back to the Menti later on. But if you have any question and you don't want to forget about them, you can just write them there, and we will go back to it later on. Yes, so let's now introduce a small Uncrewed aircraft autonomous platform data working group. So I will make a bit of background about the interest group first. So before the working group, there were like a RDA interest group that was working on diverse drone-related things, and so it started in 2017. And if you want more information, one of the co-chairs, so Jens Klump, who will arrive later on, will know a lot more about the legacy information from the group, because I only joined when the working group started in 2024. So it was developed in 2017 following the work of the ECIP drone cluster that started in 2015. And there were many presentations as part of the RDA plenary from 2019 to 2021, which led to 2 main data papers where the presenters, like the previous co-chairs, presented metadata information framework for drone data, and all this work has been compiled, and we're using what has been done before, not reinventing the wheel, but just making it even better. And in 2024, we started this group. So what is it about? So we realized that so we will call our drone RPAS during this presentation, or just drone, but we consider any platforms that are flying remotely in the sky. But we do have contribution from the marine side as well, because they have been very evolved, and also from aircraft. So a lot of people have come from the aircraft community and then use drones, and so they also bring a lot of expertise. But with the development of the drones, it has become an important tool for the collection of data in research, and they can acquire data at higher temporal and spatial resolution, and in areas that were too hazardous to go to before. And now there are lots of hardware and instrumentation that have become much more accessible, and the volume of data is also a lot bigger. So there are a lot of issues there, and while computing, cloud computing infrastructure can offer the necessary scalability, common data and metadata practices are still lacking. But we, as I said, we also use autonomous platform in marine research, and it has been well advanced. So we are also using some best practices from this discipline to potentially be transferred to the drone data management. So the objective of the working group is to collect use case of data collection and processing by drone from different disciplines to document best practices. And the goal at the beginning was to use all these use cases to give recommendation for data and metadata best practices with focusing on interoperability with the European Open Science Cloud, also known as EOSC, and other virtual research environments. And the expected output of the working group are specification for metadata and data coming from Uncrewed and autonomous vehicle used in research, and a demonstrator to support the design and implementation of cloud-based data infrastructure for drone data. So now it's been more than a year that we are working on it, and our objectives have a bit shifted with depending on the discussion, but I think it's quite nice to have the context of what was the objective and where we are at today. But we are almost at the end, and today we are very excited to present the first draft of our recommendation. And this is where your input will be very important to us, because we want feedback and know if we are completely wrong or if there are good things, and also see how we can improve them. So yeah, let's do and see how we did that. So first, the methodology and use case compilation. So to better identify the challenges and the needs to the community, the work has been based on previous work. So as I said, there was this interest group, and they had already developed some tools, and so it's based on that. And then people who joined the group also came with other information and other work. So we try to compile that together, and then to develop some specific different tools, more like templates and things like that, that we will present later today. And we had also different workshops. So we presented and had different discussion as part of our monthly meetings. We presented the first working group at P22, so the RDA plenary session, the virtual meeting at P24, and also we presented at EGU, and also at the UK NZAR community, which is a net zero aircraft airborne community. And then we had a form that people could fill in, and we collected some use cases. So you can still contribute, so if you want. The goal was to collect use case to find patterns and common issues related to the use of drone data. So you can still contribute with this QR code. And we have also a form. So with this link, you will see all the already contributed use cases, but we have also a use case. So on the document, you can add your own use case. It's really free form, and it will just ask a few questions. And the goal is to not be really, you can put everything you want, basically. So it's just a text document. And if you don't like writing and want to have more specific questions, we also have a form. So then it's a bit more driven, and it depends on people if they want to have specific questions asked or not. So anyone can contribute. We are looking, for example, for a drone, but also airborne, or also in the marine area with a marine autonomous vehicle. And you can, yes, as I said, fill either the form or directly in the Google documents. But so far, what we have discovered is that as part of the the different use cases that we have already collected, we could identify common challenges, which are data storage, image versus sensor data, data format, data pipeline, interoperability and metadata, and ethics and privacy. So indeed, for data storage, so the drones are generating very high volume of imagery and sensor data, often exceeding the traditional storage capacities. And so this was one of the first challenges that we could see. And we could see as well that image and sensor data are managed different way, and so there might require some different recommendation for each type. And then in terms of data format, so due to the variety of discipline, there is a very wide range of data format used. And it is to be noted that much of the information related to the drone, such as the position, the attitude, the altitude, are often saved in manufacturer proprietary formats. And so this is also a challenge when you want to publish the data, because you don't, like, you are kind of forced to use these proprietary formats that are not open. And so that is quite a challenge for reusing the data. And in terms of data pipeline and processing description, so there are absence of best practices in describing complex pipeline, often combining open and proprietary formats. Yeah, so now we go through the first recommendation. So we have decided to provide a recommendation through the different steps of the research data lifecycle. So for each step, so mission planning, data acquisition, data processing pipeline, data storage and interoperability, and finally data sharing and reuse. So for each step, we will have some set of recommendations. So mission planning refer to any pre-flight activities that required for a successful survey. Data acquisition refers to all the activities surrounding the collection of drone data. It is also covering some legal and ethics consideration that need to be taken into account when on the field. Then for data processing pipeline, so it's all the steps that are required to create a final product after the data acquisition. And this includes all the states from pre-processing to the final products, including also the calibration and quality assessment steps. Then we have data storage and interoperability. So this stage refers to the information regarding storage, but also ontologies and metadata recommendation to promote better interoperability. And data sharing and reuse refers to any requirement related to the publication of the output data. Here they are. So so we have them on paper as well. It's not really easy to use. They are quite big, so we try to make them readable, but we have them also on paper. So basically, for each stage, we have two types of recommendation. So we have the data-related data and metadata recommendation, which are in dark orange on this flyer, and in light colors are more like the ethics and legal recommendations. And so for each stage, we will have a recommend in the document. So if you scan the QR code, but if you can't access them, everything is also in the collaborative notes. So if you have access to them, all the links that are in the QR code here, you should have available. And so for each section, we will have the proper recommendations, which are in the flyer, but then we will have other resources and information to document each section. And also for each section, we will have a use case that highlights a specific aspect of it. So now we will go in details to each step. So mission planning. And so as you can see, for each, we will have 2 sections that correspond to the dark and light color on your flyer. So for data and metadata, so you need to choose a platform and sensors that are in line with your survey requirements. You plan your survey line taking into account the restrictions of the environment and define your standard operating procedure accordingly. Then you make sure you prepare all the required equipment and storage for acquisition before you are in the field. And you write a data management plan that documents which data to keep for long-term storage, data volume, file format, and metadata requirements. And then we have a more privacy, legal, and ethics consideration where you need to define clear purposes for data collection and communicate your plan with local communities. You get familiar with legal requirements and civil aviation rules and ensure any institutional procedure are adhered to. And you apply care principle if working with indigenous communities. So then, as I said, so I won't go into the full details. If you want to read the document, you are really welcome to, and this is the goal of this forum. But then we try to provide additional resource for each of the recommendation. And so for this, we provided links to reference discussing or giving additional information about the platform choice, example of standard operating procedures, data management plan tools, International Civil Aviation Organization state rules, publications discussing, so it's some papers discussing ethical consideration and the care principles. So now we go through the second step, which is data acquisition. So for data and metadata, we use the data collection checklist to record all the required information for future processing, and I will present the data collection checklist next. We need to calibrate, you need to calibrate your instrument following best practices. And for privacy, legal, and ethics consideration, you need to adhere to relevant national civil aviation rules, institutional procedures, and access restriction to undertake safe operations. Build trust with local communities through consistent ethical behavior, and follow best practices regarding environmental and wildlife protection. So for the resources, we have the log sheet for easy data acquisition and calibration best practices documentation and recommendation on flying drones around wildlife. So I won't go into all the details, but I can show you the checklist. So this was one of the output of the working group, was trying to find log sheets that could be useful for people to just bring in the field with them. So the goal is just a template, so you can also modify it. So the link, yeah, it's not there, but if you have the link from the main documentation, you can just download the document and then also add your own specific requirements. So, for example, Sarah will talk a bit more about it, but she is using drone from a ship, so she had additional information that she needed to record. And so she modified the template, but the goal is to have the minimum information from there. So the data checklist includes summary information about the project, but also logging information for each flight. So first you give information about the different sensors that you have on your platform, which sensor you have on during your specific flight, and then you kind of tick which is on use for the specific flight. Yeah, and so now Sarah will give you a bit more information in how it has been used more on the field.
Cool, thanks, Alice. So I am here from Ireland, and I will talk a little bit about the mission planning and the data acquisition that I do when surveying marine mammals and seabirds as part of my PhD at University College Cork and MARI. So a lot of things that at least I need to consider, and I would say lots of people who are surveying wildlife need to consider, are the platform choice that you might have. Some people have a bit more freedom with it depending on the budget and the institution and what's already available. So often times there already is a drone in an institution and you end up using that. But yeah, that sort of depends on the person and the project. Thinking also about the legislative and the administrative restrictions. So for me, it's registering as a pilot with the Irish Civil Aviation Authority, but it depends on where you're working. You might need to get additional sort of surveying or training as part of that. In addition to that, administrative restrictions that you might have. So as part of UCC, I need to tend to bring someone with me as an observer. And if we're working around other people, we need signage around the area that we're working. And then thinking about just sort of the monitoring requirements that you might have in the first place. So depending on what exactly I'm surveying, those can differ quite a bit. So in the top left corner, I'm surveying using thermal imagery to try and locate puffins in their burrows. On the top right, that's actually not taking images in the deer at all, not vertical. It's actually just replicating previously done helicopter surveys. So it depends on what you're doing and how you fly. That might change how you think about your mission planning and what you need to prepare and what you need to bring. As Alice mentioned, I often survey from boats, so that comes into the calibration techniques that you might need to do before you leave. That might be thinking about who you bring with you and if they're able to help you deploy and retrieve a drone from a boat, because that's often much more difficult than doing it on land. Thinking a lot about the weather. So Ireland is a rainy, windy place, and I've often only worked in really rainy, snow, windy places like Ireland and the UK and Antarctica. So thinking about the log sheet that Alice mentioned, I configured that to make sure that I included information about the weather so that I knew when I had issues with processing why that might have happened. And then the topography of the survey area. So can you actually do a pre-programmed flight or not? When working in Ireland, there hasn't been that much RPAS work in the past, and when working in Antarctica, that was the same. So I was often doing manual flights, but it sort of depends on the frequency at which you're going, the availability of data, and that's why we're here, and sharing data so that you could maybe use pre-programmed flights and could maybe standardize flight paths. And then sort of the remoteness of the place you're working in. Will you have connection to the internet or Wi-Fi? Do you need to prepare offline storage, whether that's hard drives, for the time being until you can connect something to the institutional servers or to OneDrive or any kind of backed up storage system there. So, and that's just to thank the Marine Institute in addition to RDA Taggart, because both of them together helped me get here. So thank you.
Yeah, so now we arrived to the first break. So we will have a bit more discussion because it's like the first step of deploying your drone on the field, and we will discuss a bit more that. So we will go back to the Menti if I succeed to do that. Yeah, so we already have questions, which is really good. So we will go through them as we go. So I will take the first question and we maybe turn this on. Yeah, I can't see the question from here. So what are... Is it working? Yeah, so what are the top 5 good practices to get into before you start using drones? Good question. I think the preparation is one of the critical points here. So before you even go to the field, this is where you need to prepare everything. And we are hoping that the recommendation in the mission planning stage will help people to prepare, and when they are not familiar with using a drone, and this is the first time they need to deploy a drone, to at least have some resources to start. So whether it's looking into civil aviation rules, whether it's going to looking at the rules for more ethical and drone flying around wildlife. So there are lots of different topics that people need to look into, and so we are hoping that the recommendation give at least an insight and a first step for somebody new to have at least a list of things to look at.
To echo Alice's point, I think there's a lot of sort of studying of your survey site that I would really recommend doing. So in addition to sort of best practices on using the drones based on metadata standards and data standards, I think just knowing what you're surveying and what's actually there is also really important. So for example, when I go to the field to survey one animal, I tend to also look up the topography and the community that lives there and the other wildlife that will be there, because when working with penguins or seals, they don't interact with the drone much, but there are other animals there that could be disturbed by the field work that you might need to think about. So some of the ethical considerations, the flight heights that are not just recommended from your permit, but are recommended from other wildlife experts. So exploring that before you go out there, and sort of what other things that you're not thinking about might happen when you get there, I would say is a very good thing to do.
Yeah, and in the resources, we did put some links to different wildlife best practices. So one is from GBIF, and then there are like different other recommendations from different papers that we have collected. But if you know also other papers or publications that you think are really relevant and that could help people who are just joining, like this is also your input that could be very relevant to us, so that we make the resource as complete as possible. Yeah. So metadata template for UAV pre-flight and post-flight data collections. So yes, so this is what we have been trying to work on, and they are available online. This is the same, so we have several researchers who used them, so mainly from Ireland, but also from in the UK. But we would love to have other people use the templates and give feedback as well to make the template better and suitable to any research. So this is really like there are no discipline-related information that should be applicable for any research. And we do have one of our co-chair, Thabo, who couldn't come here, but he's from Botswana and is now using also the template, and he's using them in the context of surveying power lines. So it's quite a different from looking at seals, so just to say. And he has contributed an example, a use case, so this is also available in the recommendation. So then automatic metadata stripping from the UAV raw data log files to ease burden of manual metadata capture. This is very good thing. I would agree with that. Then I would also say that there are some people who are really new, and the checklist is even like turn on the GPS. It's also with really like basic stuff where we have also researchers who didn't really, it was the first time for them to fly a drone, and they didn't even like collected the minimal information for the data to be reused. So it's also to make sure that you might be tired on the field, the condition might be really bad. So it's also to make also sure that you do have the minimal requirements before you even do the more complicated metadata stripping. So even if you are not recording, like the templates are very minimal, it will be just where you started. So latitude, longitude of where you start, latitude, longitude of where you end. What is the field like, and also recording some environmental information you might forget. And it might be, oh yes, at that time there is a bird that interacts with the drone, and that is something that might not be able to be then available from the log files that you have. So it's also like for other information that it can be useful for.
Yeah, I think there's a long way to go in some ways about making sort of the metadata stripping automatic, but there are ways of at least easing the post-processing, which Jens will talk about a bit more. Like, for example, I do this because I trained using boat surveys with just a regular camera, but taking sort of a snapshot in time from wherever you deployed. You can pull the lat long off of that at the end, and you can use things like EXIF tool, which pull metadata from images quite easily, and that does help when you're working with, hundreds or thousands of images. And some people are using video, so then you get into a whole other realm there. And that's something actually, I think, for the use case compilation, if people work a lot with video, I think that would be helpful to contribute, because we often work with imagery, but there's a lot there. And the video formatting and automatic metadata stripping that we could probably still learn.
Yeah, and I would just add that the goal of this working group was not to look at very specific logging file and logging system, but to make it like kind of general and applicable to everyone. But if you would like to share your experience and how it has eased your management of drone data, and don't hesitate to contribute. Anyone have questions or comments?
Yeah. Hello. So I'm Jonathan Cole, and I'm the director of the Australian Antarctic Data Centre. I'm probably in the unusual situation of I'm not a pilot, but I certainly manage a number of different pilots, so I've seen a lot of what they have to go through. I would echo a couple of things, that you do want to think about your objectives and survey design up front, because that'll determine a lot of what you need and how you will implement it. You do want to think about your regulatory framework. We run into that in Antarctica a lot, and that places restrictions, and you have to take a look at some of the challenges. One thing that I will also say is you can't necessarily leave your data organization to the end either. We've run into situations where how you collect it affects how it gets processed, particularly by some of the contractors that we work with. So these are some of the things that we've been thinking about. Just since I'm here as well, I have experience in a different space where we've worked with developing field manuals for marine sampling, and there may be a scope here to develop some field manuals for drone operations, not in the sense of, yes, the pilot training and all of that, but just in the sense of you're going out to the field, what do you want to do? So there may be some scope for that. So I'll leave it at that.
Yes, thank you, Jonathan. And indeed, and Grau, yes?
So just as a question thing, is it like a standardized, the metadata, what the drone collects? Because there are different drone types that is used for a different application. I'm just curious to know, is it a standardized way it is represented so that can be automated, just like how they have asked?
Yes, so there is two different things. So what we wanted for the data collection is that what we really need from the field to be recorded, and then we go into more details at the data interoperability section. We go through a bit more into the metadata specific elements that are required for more publishing and data preservation, so that we have all the elements to then reuse the data. So maybe keep your question for later if you don't have your answer, and we'll go back to it a bit later.
To echo what you were saying about in the field, just to go back to that briefly, I also think that I completely agree. I think if you're doing surveys over 2-3 weeks, especially in places like Antarctica, where it's kind of you've one chance while you're there. If you get back and you realize that you've done something wrong, that it's too late. So continuously checking the images and checking that things haven't gone wrong, especially with the calibration stuff. I've had that happen before, where something with the elevation was off, and then you need to start thinking about, okay, well, there's actually going to be different processing techniques that I'm going to need based on the imagery that I've collected so far and has something wrong with it, and the imagery I'm hoping to now fix before I collect it in the future. And to talk about the standards, I think it's also tricky with log files and stuff being from proprietary manufacturers. It's harder to get, I think, consistency on that, at least be able to influence that in a way. I think that's a difficult thing, but yeah, we'll get into it a bit more with Jens.
Yeah, we have a question.
Thanks. So Rakesh David from the Australian Plant Phenomics Network, and yeah, those two questions were, the second two were from me. And so I guess the reason I put those two was we're in a unique position where we have multiple nodes for Australian plant phenomic networks across the country, and they all use the same platform and the same sensor. So yeah, we are keen to see that look for templates that we can standardize for each platform type and sensor type. And I'm part of the central data team, and so it's our job to come up with templates, but also anything to ease their burden, because the pilots are, they've gone out in the field, they're tired, and they don't want to be coming back to filling in these metadata templates. So they've asked us basically to, well, rather than me trying to fill in a template and copy what is already in the log files, the truth is in there, so just try and see if you can get it out from there. I don't know how easy it is, we're still looking into it, but I just thought I'd pose that.
Yeah, good point. And in fact, the templates are kind of in two different documents. So one would be really, you describe your platform, what it looks like, and then you describe all the sensors you might be using on the field. And then in the flight, the flight one, you say, yes, I'm platform. It's sensor 1 in configuration X. And I have also sensor 3 that was on the platform, and this is it. And the goal is to not replicate the information you have for each platform or for each sensor. It's just giving names of, you have, platform 1 and 2, and in fact, platform 2 is with 1 and 2, and sensor ABC, and so on. So the goal is just to say, I know that this flight, the configuration was like this, and so that you can kind of fill in the first part before you go, and then just say, it's ABC1. And so it's quite easy, in fact, on the field to just record that if you have many, it's easier at least.
Hi, question. Donnie Johannesson, QUT. Is there restrictions in data collection because of the drones in the sense of battery life, flight time, weather, obviously, as you mentioned too, Sarah? So how do you capture missed data?
Good question.
And also upgrading drones, maybe that's a way as well.
Yeah, I think that's a really good point. I mean, as drones progress, you're able to collect more and more, and I guess you almost sort of have to think back to the things you didn't realize you didn't get as you get new drones and they're able to collect information that you weren't able to before. I think that's quite tricky. I mean, when I'm in the field, I tend to note something like that down just immediately because I probably won't remember 3 weeks down the line that survey number 3, the batteries died. But the battery life on drones is a classic problem, and the harder the survey, the faster the batteries die. So that's something to think about. I mean, sometimes that comes back to the mission planning. I've done surveys in South Georgia where you're working on a rib from a ship, and as a battery dies and you swap it out, we would put it in a bucket and take it up back to the ship. They would plug it back in, and I'd keep flying so that you could keep going and have this circular effect. That's not always possible if you're in the deep field or if you don't have, battery packs and stuff. But that's sort of something to think about. It's like, okay, well, what are the limitations that I might have in the field, and are there ways I can think about, trying to account for that before? And if there aren't, then noting it down in the moment, just to keep in mind, oh, well, like on that log sheet, I put, like, is it a full survey or not? Because often with animals that you have, tens, 20,000 penguins, you're not going to get a full survey. So noting that it wasn't a full survey, but it's a subset, and you could maybe use that as a proxy for what the overall population is doing. You could do something like that to kind of account for that. But I guess the big point of it is writing down everything that you need to know in the moment, and then thinking about that after, and thinking about what that could teach you for your next survey would be what I would say to that. But yeah. Did anyone else have anything?
Thanks for this. I was at one of the first meetings back in Philadelphia, and so it's great to see how much has happened since then. Peter Pulsfer at Carleton University. I would just suggest on the point about apply care principles and working with Indigenous communities, I've done quite a bit of drone work with communities, and one thing I would say there is, depending on where you are in the world, you may want to consider, if you're on Indigenous lands, whether you're working with the communities or not, that you need to consider that. And it'll be different, I think, by jurisdiction. But in Canada, I mean, it's recognized now the entire country is essentially Indigenous lands. But there are some, for example, that are under land claims agreements that you may not be aware you're on Inuit-owned lands if you're on Baffin Island and you can be doing a drone survey. But often people are not working directly with the community if they're doing, permafrost or something like that, but they really should be checking in with the community, letting them know they're doing that, even if it's just for the community to say, okay, thank you for letting us know. So for that particular point, I just encourage people to really think about the nuances of where they're working.
Yes, thank you. And in fact, Jens Klump, who should join us, we are hoping very quickly because he's supposed to present next month. He's doubling up, so we are sharing him. But he has, he contributed to one example where he was flying over a land in Australia, and here it is. See, we were calling him. And, so we can discuss this a bit more also at this time. So if you want, we can also just rate and see what people are feeling about the first part of the recommendation. So how would you rate the recommendation? Like we don't know how to get feedback really about the recommendation. So this is a first step for us to have a rate of what we should improve and what we should do. At the end of the presentation, I will share a QR code as well, and they are available in the collaborative notes where you can have a form and you can give your inputs as well. And if you are contributing a use case, you can be also considered to be added as the author of the recommendations. I just put this like this, and I don't know if people can. I'm not sure you can wait or not. Okay, I will wait at least 5%. 4. Don't know. Maybe a fifth person? No? Okay. That's fine. Oh, we got 5. Thank you. 6. Even better. And it's getting better, so I don't know what I did. Yeah, thank you. Yeah, and then I will still have this open, so if you have an idea while I speak, you can still put them here, or if it also is a question that you might have over the presentation, we will go back to this part. Yeah, so yeah, in fact, it can be any question you might have from the following part of the presentation. And I think, oh, that's not bad. Yeah. Yeah, and I think, Jens, it's you. Yes, so we go back to our recommendation. Now we are at step 3, and it's about the data processing pipeline. The recommendation, I can't see anything on the screen. This is very, no. Sorry, well, I can't see the screen, which is very annoying. So, in terms of data and metadata, we'll need to document the processing workflow following the data processing checklist. So we go to this part a bit later. And separate row, so that you can kind of call level 0, pre-processed level 1, and process data level 2 onwards, and use version control. Then provide a quality statement giving insight about quality assessment and control, so apply to your data. And in terms of privacy, legal, and ethics consideration, you need to blur or anonymize personal data if applicable, and reduce the precision related to sensitive locations, so for example, related to endangered species if applicable. So in terms of links and resources that we have provided in the document, we provide link to description of processing level, list of processing metadata, and there is a very nice privacy handbook that has been published by the European Aviation Safety Agency that you can look out for, and also best practices for generalizing sensitive species occurring data. So this has been published by GBIF.
So you might have spoken about this before. We didn't reinvent anything. We looked at existing best practices, and so this is referring to what we learned about or knew about.
It's different. I don't know. Sorry, I'm trying to get the slides. Yeah. Yeah, so here are the data processing checklist. So for each level, we have tried to look at different metadata that are required. So we are referring to raw, pre-processed, and processed. So some people give a name like a level 0, 1, and 2, but this differs for everybody. So it was just a number that we gave, but we acknowledge that depending on the community, you might start at 1, while others start at 0. But what we meant is that you have like kind of the data coming out of the drone, and then you do some calibration, you arrive to your pre-processed data, and then you have more the processing pipeline. And so, for example, for level 0, you might need to have a mission identifier, sensor specification, platform information.
So platform details. Your drone will probably record flight parameters like its altitude, speed, and heading, and Also maybe specific details about things that you record in the field, and then a description of the type of data, output format, and description variables. So this is on the very basic technical level of what the drone does and what comes off the drone. And then, the next level, pre-processing, which inherits what you got on level 0, but now you do calibrations and you document that. You have an idea of what the quality was and the quality checks you did, the georeferencing you used, any corrections you applied, and you describe the software that you used for that step. And again, describe the data that you output from this step. And then you come to the step that we found quite difficult in our Australian Scalable Drone Cloud project a few years back, where there was no standardized way to describe what we then actually did when we did the processing of the data. And so again, you inherit the level 0 and level 1 data information, but now you have to describe the processing that you use, the algorithms, software versions, reference data that might have gone into it for calibrations and validation, spatial resolution, and so on, and again describe the outputs from that step. And you might have further steps. It's turtles all the way down.
Oh, yeah. Yeah, so now we are step 4. For data storage and preservation, so the data and metadata recommendation are to use recognized metadata standard used in your discipline and follow the recommendation for specific RPAS metadata. Use open formats where applicable. Adopt ontologies to enhance semantic clarity and interoperability. And utilize persistent identifier for instrument PIDs for accurate referencing and traceability. And in terms of privacy and legal ethics and ethics consideration, to establish secure storage with access restriction in alignment with the requirements.
Which sounds very abstract, but sometimes you can just be open about your data, but there are legitimate cases, and we'll come to one of those a little bit later, where there are good reasons not to allow unrestricted access.
And for this, the resources include metadata information, list of recommended formats, list of recommended ontologies, and link to PIDs. And now we'll dive in a bit more into details of the metadata. So it was to answer Guru's question. So we consider that there are different levels in the metadata that you might use for your RPAS data. So you have the discovery metadata that can be quite generic, so a title, an abstract, who did collect the data, so authors, that date of publication, date of collection, but this is something that you might see for any data sets. And then we have some more specific RPAS metadata. So we have things that are really common for metadata that are common for both image and sensor metadata, which include information about the platform. For example, you can have information regarding the payload or the stability, and then the sensors, the calibration parameters, the project, and also the information regarding the quality of the data. And then we have specific metadata that are specific for images or sensor data. So for images, you have image type processing, but also resolution, for example, that you might not have for a sensor data, where we will look at more variable measured and processing. And then you might have also some specific domain-specific metadata that are most of the time also to ontologies. You might want to use ontologies from your own discipline so that it's interoperable with other systems that you, or other data that you have in your discipline. And then we have a list of recommended formats, but this is just a list that can be also just to give something. So it's just a list of formats that are depending on the type of data you might use. But in each case, we're trying to use open formats and one where you add embedded metadata so that it was easier for long-term preservation. So we give also recommendation, for example, on how to add metadata to images. So there were work from the NCAS, so the what is NCAS? By NCAS, you will. It's the Atmospheric Centre in the UK, and who developed some guidelines on how to use tools to add metadata to images, for example. And then for CSV, for example, the UK Polar Data Centre developed what we call XCSV for extended CSV to add metadata within the file, but there are other solutions that exist. But the goal is to try to preserve the data and the metadata together where possible. While some formats like NetCDF, it's already embedded and you can add everything directly in the format. So now we arrive to the data sharing and reuse, which is the last step. So you have made it so far, so congratulations. In terms of data and metadata, so share your data through a trusted data repository using open format and all the necessary metadata required for reuse. And in terms of privacy, legal and ethics consideration, adhere to privacy laws and ethical guidelines, particularly regarding sensitive data, by following the principle as open as possible, as closed as necessary, and defining a license in line with the requirement of privacy. So for this section, the links are to the RE3 data repositories, definition of open science, and link to open licenses. And then example. So it's an example from the UK Polar Data Centre, and we have two really different cases. One that is more, so on the, I don't know my word. So on the left, yes, so on the left, it's gravity data that have been collected in West Antarctica using a large drone. So you can see a picture, so it was a very large drone. And in this case, it was more replacing an aircraft. So in fact, this is where the information from the aircraft community comes in. And in this case, it was more sensor data. So we had a sensor collecting gravity information. And in fact, in this case, it was quite easy because we had all the techniques that were already developed before to handle gravity data from aircraft platforms. And so we tried to replicate them using a drone. And so we could then ingest them into the Polar Airborne Geophysics Data Portal quite easily, and it was fitting with what had been done before. But then we have an example of first seal colony survey that was collected in South Georgia by our mapping team at BAS, so at the British Antarctic Survey. And so each flight produced numerous output, which involved a different level of processing. And each data set contains up to 3 levels raw data, so it was GNSS files and image files, post-processing files, and different, and then also the output as a surface model and a digital surface model. So the data that were derived from the images in this case, so the colony counts, have been published in a separate dataset, but the dataset were relatively large and raising issue of data storage. And in addition, the numerous large image file proved challenging to check because it's difficult as a data manager to check each image one by one when you have thousands of files. So this was our usual technique when we had images, but it was impossible if you have thousands of them. And in terms of quality control, the large number of large files proved challenging to check as well because our workflow were not fit for that, and the images were really big, and so slowing down the computer as well. And then we had the UAV log, as was mentioned earlier, that were in proprietary format. So while we don't accept usually proprietary format for publication, this is only this kind of our exception at the UK Polar Data Center. But if we wanted people to reuse and be able to reproduce all the steps, we had to still provide the raw data, so we still did that, but we are not very happy with that, I have to say, but it was our only solution at this stage. So there appeared to be no appetite within the industry at present into converting the data into open formats, so it was difficult to comply with FAIR principles. Yeah, so at the moment we included it at proprietary format, and yes, so while one example was quite easy to handle because it was from sensors that we knew about before, we had a lot of issues at the UK Polar Data Center dealing with more imagery and large data sets. So there are still ways of improvement, and we are hoping to make it better, and so that's why we get involved in this project. Yeah. So I think it's all we have in terms of like recommendation, but it's not finished. Because we have a discussion again, so I will launch again the main thing, and I see that we already have a question. Oh, it's a missing. Very good. So local testing of equipment and mission flight to ensure it is fit for purpose. And we do have a bit of a mention of it in the additional information, but it's not maybe clear enough. But we can make a note of this. Is there any question?
Thanks. It's Jonathan Cole with the ARDC again. This is, I guess, I have two branching questions which might be a little bit further down the path. Within your steps, where do you see, so the first one is, within your steps, where do you see frameworks like STACK fitting in? Like spatial temporal asset catalog. It's not quite a format, it's not quite a pipeline, but at the same time, it's a delivery mechanism. Do you see that sort of fitting in anywhere?
I think it's also part of the last question we have, because if you remember the presentation on the objectives and integrating on big virtual research environments and so on, we know that we haven't achieved that. And this is where we got a bit stuck, but this is where it needs more information, and I think you can contribute, because I think you do use a lot of Stack.
We do.
And maybe you could contribute and give us some advice.
Yep, that's I know who to put on it. And then you may have pre-answered the next question, which is we've heard a lot at this at International Data Week about AI ready and whatnot. So what would you see as some of the steps in particular, not just the imagery access, but also the processing steps? How would you see sort of getting the remotely piloted aerial data ready to face the brave new AI world?
It's a very good question, and maybe I will even yeah, I mean, Jens, if you have any comments on that. Because we did discuss a lot about the data processing pipelines, and we tried to gather information, and it was the most difficult part and the focus of many meetings. And in one of the examples from the UK CEH, so they are leading the FDRI, the flood and drought research infrastructure, and they are using lots of drones as part of this, and they are trying to build an ontology, and so as part of, they were part of the monthly meetings, and so as they were like developing their own ontology as well, it was a really good input as well. And so we are trying to identify points, but in fact in the literature we have not found an easy way to describe that. And so this is the way where we see a big gap in this domain. And so on how do you describe all the steps? Especially when you have proprietary open source, it's quite difficult to really put, oh yes, it's just this code which made what A to B, because in fact you can't do the first bit.
It's an early question, and so you could very easily say, watch this space, and you know.
But I think it's almost like a RDA full group that needs to work on it.
Yeah, so that's something to think about, you know, as part of the development of this. You may not be able to solve it here, but that doesn't mean that it's something to be worked on.
What I see as a challenge is that in the processing, it becomes very application specific. And to then just say we use this algorithm might not be enough. We have to then also say how it was parameterized. But then that's very specific to this algorithm and this use case. How can we generalize it? Or can't we? And we just have to refer to, well, it depends on your specific implementation. That's the kind of questions that we kept on discussing. And how do we make this step seamless from our little localized platforms and sensors feeding this into things that run in the open European Open Science Cloud?
Sort of what's the lowest common denominator patterns, and they may be unsatisfying in terms of technical, but I see this in programming a lot, where you have the abstract concept and then you have the implementation, which has a lot of detail. So you can piece together the abstract pieces, say you must do these, but then maybe there are pieces underneath. I don't know.
Yes, that is what comes to mind. But thinking of our experiences in the Australian Scalable Drone Cloud, we decided we wanted to find that least common denominator to then build specific tools that could be chained together, and that turned out to be extremely difficult. And in this particular project, with the common denominator we found was the image processing to arrive at an orthophotomosaic and a point cloud, which is a great starting point for many, unless you're dealing, say, with geophysics data or atmospheric data, then it's not an image. But the really interesting parts happen after that. So how do you then describe on this very generic platform that handled vegetation data, geological structural data, geotechnical data, and ecological data, and atmospheric, and so on? How do you then, where do you stop, or where, yeah?
Well, it's, here, maybe I'll, rather than continuing the show. I mean, this is all the hallmark of a good discussion. I also have the luxury of having been involved with a number of satellite processing projects as well as multi-beam processing projects. And there is this common pattern of different levels of the transformation of the data. You have the raw satellite data, which they call level 0. You have the geo-corrected, which is level 1. You have the full, sort of product space at level 2, and then you have the derived product after that. So there may be analogs, and you will have surface reflectance imagery versus radar imagery versus microwave imagery, all which will generate different products. So there may be, you would take the equivalent and generate ecological analytical products. So I don't have an answer, but I do think that there are patterns that I've seen before in the multi-beam space and in the satellite space that you might be able to draw on.
And I think that that's a very good suggestion to look at those patterns and then look at the differences. Because what I see as kind of characteristic of the satellite scene versus the drone scene is that the satellite scene is pretty organized because it's so expensive to do, and then you have defined products, and even what happens after those products then becomes zoo, but that's fine. You have you have a set of defined products, and then you describe the processing chains that lead to those products. I see the challenge in the drone space in its fragmentation, that it's so easy to just do your own thing. You don't have to coordinate with anybody. That it will be difficult to find a common ground. But that doesn't mean we can't learn from the satellite community, and maybe we should, in the recommendations, pick up the satellite example as this should be best practice. Yeah.
I think one of the challenge with the drone one is that a lot of people use a proprietary software to do the processing, the level 1 side of the thing, and that is not exposed as a process. So PIC4D or other things, that is one of the big challenge. So you can just lump it as like, and we call that as a method or a process, and then when it's come to level 2, then it's where like users start deriving, then we can put it as like a process chain. For example, I think SensorML used to do it very well, like a process list kind of a thing. So probably something like that, you can look at it, at least to describe that. We may not have like a complete reproducible thing. At least we know that, okay, that has been processed by PIC4D, for example. That kind of an information probably is taken care of.
Yeah, thank you.
Just one more piece on that, and again, I've seen these patterns before in that in the satellite space, they've developed things like the Open Data Cube and also GDAL that help break out that former piece. And in the multi-beam space, they're kind of at this awkward where they have the commercial packages like Keras and Chimera, which do the full processing, but now they're trying to break that apart into the open space. So I think you may see something here as well where you've had these commercial packages, but then it will take some effort to break that down into an open package. So it's worth looking at some of the patterns that have happened in some of the other domains, and you're not alone.
I think it's already happening. So they process it. So for example, in our project, it's processed using PIC4D, and then we create a cog file, and then L0, L1, and then we split it into multispectral, LiDAR, and then convert it into COPSI cog file, and then publish via the stack. But the exact processing, for example, I think when the project was started, they want like its complete reproducibility aspect, so that the method can be pulled to the process and then some other people can use it. That is a bit hard, partly because now most of the drone people are so used to the commercial product, and then fine-tune their processing to that one, so that is not exposed. So that is a bit of a challenge. Once it's processed, it comes to the L1, then we can pull that and then generate as a open standards, and then if we want, we can push through the open DAP in an open cube and then everything. So that is possible already. Yeah.
Yes, thank you. And Peter has a question as well. Just as it will be like the last question, I will just enter what is on the board, and then we continue a bit because we have 10 minutes left.
Great, I'll try and be fast. So just looking at this, it's very educational, I think, by design. But as an educator, I'm wondering if you have thought of or are already thinking about more formal educational materials for use. For example, I teach undergraduate geomatics courses, and there's a lot of interest at that level. All the third years and fourth years are like, can we play with drones and can we do all this stuff? But I haven't yet seen a lot of material out there, so I'm just wondering if you've had any of these discussions about using it in classrooms.
No, but it's a good suggestion, I think, and because like in terms of timeline, I haven't really presented it like in full, but we still have till January as part of this working group. We think that our combination, I think we have a first step, and the goal is really to look for adopters and look for as many people to look at them and give feedback. And we do have this session was also to look at gaps, and so we have already identified big gaps with like the processing pipelines and how to make it better. And in fact, the final recommendation will be with an additional section which documents at least the different missing things and parts that can be improved. And I think it would be nice to add this part where training materials could be a nice addition.
Certainly, as an adoption use case, this is a great suggestion.
Yeah. So just because we have people who also put some comments here, so it will be useful to have a DMP template and flight path information. So for this, I think it really depends on your project. So I think some DMP tools kind of run you through the different questions you might ask yourself as part of DMP, and I think it's already quite good to still go through that step. There might be some, I'm not sure if we have open DMP example, but that will be very specific to everyone's project, so maybe it won't answer most of the question. While we do have SOPs that are really like drone stuff that we thought were more useful for people. And as part of the DMP, you can choose element, for example, the formats. We have a list of formats. In your DMP, you can say that you will be using the template that we have recommended as part of this. And in fact, you can use the recommendation as a basis for your DMP, saying, oh, I will follow this document to handle my data. And that would be kind of a good stage already on how you manage your data as part of your project. And keep your operator license up to date. Yes, I know it's a challenge, but this was not really the main objective of this recommendation. But we can put a note that this is something to keep in mind, that you need to keep your license up to date to be able to fly a drone. Yeah, go.
So one of the things with the DMP is because with the drone, there is a lot of the country level legislation that needs to be taken into consideration. That is why the template would be useful to prescribe that. Look, you need to, I think somebody mentioned that, on the indigenous thing. For example, in Australia, you can't fly without the CASA license, kind of a thing. And then you can't fly on like a, the human thing in Australia as well. And then the privacy, all this issue. So those are the things that should be, at least there should be, people should know about that one. Especially if you are looking at that, that needs to be taught in a university kind of a thing. So they should be aware of that one. They can't just go and fly anywhere.
Yeah, and now it's time to race again. if you go back to your phone, and we'll try to reach the 5% mark to rate the recommendations. And yeah, if you have any feedback, yeah, so I will just wait for you because you need to log in again. Then, yeah, we'll. Yeah. We have one person.
So that's very middle of the road, so a lot of work to do.
Okay, we have 6. I think I will just move on because we are 3 minutes. Yeah, and this is done. Yeah, I will just go back because Jens, you can discuss about your care principle really quickly. Example, and I will put the slide up.
Guru already mentioned briefly that there are other considerations that sometimes need to be taken into account. We tiptoed around this a little bit without talking about there's ethics and whatever considerations. And specifically in the case in Australia, we have the situation that there are the modern day legal owners of land that need to be consulted when you go onto their land. You can't just go there. That would be trespassing. Sometimes those are government bodies, if it's a national park. But then there's also the traditional owners of the land that also need to be consulted. And there are more areas now that are covered by native title agreements where this relationship is formalized. And so in the recommendations that we give for Australia is that you should find out about who do you need to talk to whose land are you accessing in the modern sense and then in the traditional sense. And with the introduction of native titles, there is always a prescribed body corporate that is the representation of the communities on that land. That would be your first contact if you don't have any other contacts, but it's not sufficient. And it's a slow process of winning trust because you're moving onto somebody's land. This will also inform you about cultural considerations because what you image might be neutral from a modern Western perspective, but from a traditional owner's perspective, some things have limitations of who can see them, who should see them, who should not see them, and it's your responsibility to make sure that you respect those cultural norms, not just your own cultural norms. So I'll just stop there because we're at the end of time.
Yeah, so thank you everyone for participating in this session. You are welcome to give feedback or contribute with the use case through the form or through the different links we have provided through the session. And my email address is also in the collaborative notes if you want to also chat or join the group. You can join the group also online with on the RDA website. And thank you so much for your participation. And yeah, thank you.